we just give you a quick overview of how we're doing overall as a business. Let me tell you now, we're gonna click, and then we're gonna double click down, and Gary's gonna actually go into some of the internals, because you guys really want to see what the hell's happening under the covers and how do we do it. So how do you build massively scalable storage? So one of the things that, we touched on some of the big aspects of it, but first it's commodity servers. You've got to take the advantage of, basically, you look at the Intel commodity server market out there, the cost points that things are at right now, the densities that we can achieve, and the innovation that's happening. This cycle what's happening with Intel is the tick-tock of the Intel cycle, where 2 releases effectively are going out every year. You're getting faster processors every year. You can't go into the world today of storage where you're building customized ASICs for this capacity storage market. You got to take advantage of what's happening in this commodity server market. You got to take your software-defined storage, lay it onto these commodity servers, and you'll get a much more efficient platform. Not only that, we can actually sit it on top of course, heterogeneous storage platforms. You're going to see a little bit later on about what we do in terms of vNodes, which is a specialization in terms of how do we actually optimize I/O so that we can actually balance big fat nodes with smaller nodes so that you get a balanced capacity use across the entire cluster. So standard commodity servers, it can be heterogeneous nodes, and multi-tenancy. This is really core to us. I'm going to double click on this in a little bit. Every application, it's not just about groups and users and how do you manage access control and ACLs and all that. We have that built into the platform. But it's how can you actually take stuff that's pretty hard, stuff like decisions on whether you want to use replication or erasure coding or quality of service, and actually manage those on a tenant level, so that every tenant effectively gets their own storage pool. And this is really quite cool. So what you've got is the ability to actually take one tenant and say, I'm going to use erasure coding on that, and I'm going to have it as a multi-data center erasure coding. So I'll have erasure coding plus mirroring for that piece of data. For the second one, I'll actually use replication.
So are you implying that you don't do dispersal?
We do dispersal. Yeah, okay. So it's a dispersal algorithm, but we can do it on a per tenant basis. So what's really unique about this is you've got a platform that on every one of these tenants, they can actually have different policies and even different replication policies. So at the same time, you can have replication running and erasure coding and different techniques for erasure coding running for each different tenant. And we'll show you that in just a second. And then, of course, it's scale out. You can add nodes on the fly. We're going to show you how we do that. I think if you look at things like Isilon prides itself on simplicity. Simplicity is key. Storage, if you don't make it dead easy to actually add nodes or remove nodes on the fly, you don't have a very good storage platform. One of the problems with object storage up to this point has been the complexity of the platform itself. So you'll see a lot in terms of management improvements that we've made to really make it dead easy to add nodes, remove nodes, scale your cluster as you need to go. So let's double click into it. So the platform supports erasure coding. So basically, splitting data across single data center or multi-data centers. You can actually enforce conformance of erasure coding to say that I actually want to keep data locally, because erasure coding is going to shard data, and it's going to then, if you do multi-data center, you're going to be paying a latency penalty based on whatever that network is. So you can enforce locality constraints on the data, or you can decide to actually do dispersal across data centers. You can choose replication for certain applications, collaboration. We see it very common that people want to use collaboration on data. Another very common use case is actually when it comes down to distributing data. Often the combination is very beneficial, because if you've got multi-site, and Mike mentioned that over in Japan they had NTT, and we built this by working with really, really large service providers. But when you have multi-site, you're going to have to take data and distribute it, and really replicas are a very efficient way to go there, to actually move it across if you care about latency at that remote site. Compression and encryption are both built in at the server side. Gary will actually show you how they're controllable through APIs and interfaces. Everything we do is controlled in that way. And then the tiering. One of my beefs about the storage market has been the gateways. This idea that you have a storage array and then you stick some separate gateway that's actually going to manage distribution of that data up to the cloud. That gateway, and particularly in the capacity storage market, that gateway needs to be built back into the storage array. No longer separate. It needs to be part of how we manage policy of data within a storage array. So that's what we've done. We've taken basically gateway functionality, we've built it into the storage array, and we automatically can tier data then based on your policies out to Amazon.
And do you have like accessor nodes and storage nodes, or how is that configured?
So no, it's true peer-to-peer. So every one of our storage nodes, every system that's down here that's actually running our software is running a complete set of the software. So Cassandra is distributed across all of those instances. On every one of them, you've also got the S3 server, so we're basically taking the API, understanding that. All of the QoS is managed, again, in a distributed way. And that's on purpose, because the going through a single node and then kind of managing redistribution, what you end up with is multi-hops. And we're trying to reduce as many hops as possible. So one of the things you'll see in some of the competition is as you scale systems, the number of hops start increasing, depending on how they've implemented things. So we don't have that. So every node has a full distributed view of all of the data. And this is one of the big reasons why we use Cassandra. And Gary will go into some of the advantages, but also some of the things that we had to fix in Cassandra to make it work as a storage array. Cassandra's not built for storage. It has a lot of the right attributes.
Are you using Cassandra to store the objects or the metadata?
Store the metadata. Yeah, actually that's where you find Cassandra doesn't actually scale very well when it comes down to big data. And so a lot of what we're doing is just storing metadata, and you'll see a lot more depth from Gary on that one. So a lot of capabilities built into the platform. It's natively S3, so every one of the nodes is a native S3 interface. And yes, we've made a bet on S3, and we're proud of that bet because all the application ecosystem is actually S3 based out there. Huge application ecosystem, over 400 applications that are available. All of your backup applications, your archiving applications, a lot of the people that we're working with have already made the bet on S3. So people like media and entertainment companies are already building their apps as S3 apps. In fact, they already have quite a bit of stuff already running in Amazon. So we make bets on that, geo-distribution and scale out. Smart support, you'll see a little bit in terms of how we actually automatically detect diagnosis from our systems and actually run it through Hadoop analytics and actually come back with recommendations back to our customers. And then quality of service and billing and reporting built in. So again, it's multi-tenancy. If you're going to have multi-tenants, it's a self-service, multi-tenant cloud platform that you can deploy in your data center. If you're going to have that, you've got to have the ability to control those groups of users. So you've got to have quality of service built into it, and you've got to be able to do chargeback policies as well, or cost awareness, at least cost allocation. The policy engine. This is one of the key things. So maybe we'll whiteboard a little bit on this. But what's really important is not all applications are the same. If I've got an application up here, which may be, a backup application, and I've got another one, which may be a smaller amount of data, which is collaboration. Those need different types of needs in terms of storage. In fact, this one you care a lot about capacity efficiency. You're streaming in basically big objects, so you're not too worried about latency on a per object basis. What you care very much about is being able to stream large objects in sequential latency. So latency is lower priority. Bandwidth is still high. And over here on collaboration, you're probably multi-site. You very much care about latency on a per object basis, and the objects are generally smaller. And there's probably many objects that are sub, say, 50K in size. So they're very different use cases. So building a platform that can combine those two use cases together is rather difficult to do. If you just go and do a system-wide setting and say everything's going to be erasure coding, you're going to really suck on the write. Your collaboration won't work very well. If you're going to do it as a replication setting, your backups are going to be really inefficient. You're going to be wasting a lot of storage.
So just other than potentially a little bit of saving in hardware, why would you put them in the same platform?
Why would you put them on the same platform?
Yeah. Well,
Basically, the whole goal of this is that you can deploy it as a cloud service, just like Amazon. Like, why do you actually use Amazon? Why has it gained so much adoption? It's about this. These IT departments have to become a service to their end user groups, and they have to allow self-service for those end user groups. And those end user groups actually understand the policy for the data. They actually understand their applications and what the business needs are for those applications. So what you really want to do is empower your end user groups, give them the ability to actually manage the policy that's appropriate for their data sets and their applications, and then do it in control. So like we said, it's fully multi-tenanted, and the goal of it is that you move away from one size fits all, or an IT department, I'm going to go and build deploy a system, here's my erasure coded system. Everything you have has to go onto that erasure coded system, or, oh, you need collaboration, let me go and deploy another system, which is totally independent. We should just deploy a cloud infrastructure into our customers. On those customers, they then can choose and decide based on what their application needs are, what policies are appropriate. So that's what we allow happen.
So when I think of, can you reference when you say customers? So you guys are heavy in the provider space.
Heavy in the provider and in
the enterprise. So when I think of customer, I think of customer from the enterprise perspective. And I'm not sure if I buy that the application developer in an enterprise knows the policy that he needs.
Yeah, they actually do. So usually it's not an application developer. Usually it's kind of department IT people who actually really understand it. So it's not per se end user, but it is business groups. And so those business groups, so we've got an example of a customer over in Switzerland. Casale is the name of the company. And Casale actually use it. They got a backup team who actually is responsible for all of their enterprise backups for their VMware environment. They're using Veeam for that backup. They're streaming all of that into one pool or one bucket of our storage.
So from a enterprise customer, so if I control kind of this platform,
yeah,
help me understand who's the customer in the enterprise. Is it I'm the private cloud provider in the enterprise. Is that the IT group, and that's who you're referencing understands the policies, or their customers?
So it's absolutely, so who's the customer that we sell to? It's the IT group.
Right.
We're providing them with a cloud infrastructure. What we're trying to do is oftentimes there are specialist groups. Like if you go into an IT organization, you'll see the specialist groups who are running the ERP applications. There's another specialist group that's around the Windows servers, which is generally where collaboration is. You got the VMware guys are usually managed by the VM team, and there's the VM admin team, and they're usually related to the server team, so the sysadmins kind of guys. And then you'll have the storage guys who usually are responsible and tied with the backup and archiving. So they're actually different IT teams who all understand the business needs that they have, but every one of them has different requirements. So if you go back to this one, this is where you want to have erasure coding. And I might do a 10+2 erasure coding and decide that I actually will distribute that across multi-site for DR protection. In this one, I'll do replicas, and I'll do a 3-way replica. And not just will I do a 3-way replica, I'll actually decide that I want to have it in 3 data centers, because I actually want to collaborate across those 3 data centers. I want to collaborate on those objects. So very flexible.
I think my challenge in understanding this is that I'm giving a development team, a internal IT team, a platform on which they can build applications.
Right.
And they can store data. And from a traditional IT perspective, storage administrators normally don't do that. So that's kind of the struggle I'm having. Who actually controls this platform? Who helps set up these policies?
That's exactly right. So that is the absolute key thing. So effectively we have multi levels of admin. We've got effectively a system admin level. We've got a group admin level, and then we've got a user. And what your system admin level is able to set is what the infrastructure can support. So the type of policies that you actually think are supported within the infrastructure itself. Your group admin is the key person who's going to set up these pools of storage and actually associate with those pools of storage which policies are allowed. Whether you want to do replication across these 2 data centers, that becomes policy replication, or I want to do erasure coding and do it local. That becomes my backup policy, right, or my efficient store policy. So effectively, each of them are have that control. Now, the second piece that we're able to do is we're able to do chargeback or cost awareness on this too. So everything that we have is monitored. We track all use. We track based on bandwidth and I/O. There's basically a whole table of stuff that we actually do in terms of that chargeback. And you can also set different cost points on that. So what we're trying to build is controls for the admin team, because you can't let it just be go do whatever you like.
Right.
Right, and that's absolutely right. So what we do is we set these controls, and the background for us is service providers. There's no way that NTT as a service provider would let their end users just do whatever they like. But I think all enterprise IT organizations are going to look like service providers. And that's the big change that we're seeing, which is to do that, multi-tenancy, ability to control kind of policy about how you store data. Even when you're storing small object sizes, we optimize those. We actually stick them in like metadata into Cassandra. So you have to change that dynamic. You have to change that dynamic of how IT operates.
Yeah, so hopefully you guys will get into kind of the management stack of that and how you look at it, because when I think of the kind of the management approach you guys are using, I'm thinking this is a part of a larger system such as OpenStack or some other CMP that would hook into. So I would like to see kind of how does the chargeback system work, integrate with like Nova or whatever.
Absolutely, we'll actually show you quite a bit on the management. You'll see quite a few kind of small little snippet demos that give you that sense. And we've done full OpenStack and CloudStack integration and plugins. So this can basically be a service in behind that.
You told about the backup utilizing Veeam. Why didn't they use Cloud Connect from Veeam itself?
So they do use Cloud Connect. So Cloud Connect is basically the connector that is an S3 connector. Instead of actually sending it to Amazon, they stream it into us. The reason why they do that is actually they wanted to have, they felt they could get better performance off it by streaming it into us as a local storage pool. They also have the ability, as you'll see later, to archive their data still to Amazon. So they kind of get this best of both, where they have a kind of effectively an S3 storage pool available to them, and they can tear up to the Amazon cloud. So it came down to cost effectiveness of the solution, the ability to have controls over their data. Before we send data up to the Amazon cloud, we can have it fully encrypted, so you don't have Uncle Sam going after your data. Those kind of things, which are really important. Yep. At least if he's going to actually come and go to you as a company to try to get access to your data, not access to a service provider.
Okay. So sorry, Paul, I know we want to move on, but can I just re-emphasize that point? What is there any other value add other than having it as a single platform that you're providing by having one system that's doing all of these features? And the reason I say that is, is it good to have one system that tries to be everything to everyone, or should you be thinking, if you're big enough, separate systems that are good enough and they're very specialist to do one job and something that's specialist to another? Is there anything you're doing that's value add that sits across the top?
We think there is something that's value add. Actually, one of the important things, I didn't mention the adaptive policy engine side. This is completely dynamic. So one of the challenges with storage, and I've been at it for a long time, but one of the challenges is you think you need a particular thing. I think I may need replication for this particular application. I'm going to store it with replicas because I think I need a certain latency off that. And you find that the usage really doesn't demand it. Well, what you're able to do is dynamically on the fly actually go in and change the policy. And so I can change the policy actually to erasure coding and then store the data much more efficiently from that point forward. So what you really get to is not over-provisioning storage in the way that we've been doing before. We've been overbuying and over-purchasing storage. It's very difficult to right-size, to know up front what your application demands are and deploy them onto the system properly. Instead, you can deploy them onto the system and you can change the policy on the data when you need to. And that's a really important factor. So you can change any of these policies dynamically on the fly. I can change how I want to redirect small objects. I can change data center policy in terms of which data centers I actually want to move data to, all dynamically. And I think that's a key thing that you often don't know. So it's more than just having the ability to have them in one big pool. It's the ability to dynamically change those policies.
I would actually counter some of that, but I'm not going to do it now because I think otherwise we'll run out of time. But I think that's a management issue, and that's how effective people are at doing things. But
let's show you actually how we do it. As we drill into it, and Gary drills into it, you can see how we do it to actually manage it relatively simply. Quickly on object size, we're actually able to manage it in terms of small objects. Everybody talks about capacity storage, and they talk about big objects, megabyte, gigabyte kind of objects. And we do multi-part uploading and chunking of objects and all of that usual stuff to store them efficiently. Reality is that in many instances, 50% of their objects are really small objects. And if I go and take those and erasure code small objects, good luck.
Been there, done that, didn't work so good.
Been there, done that. It just does not work well. So what we do on this, a very simple policy, it basically says, you're able to kind of select based on the size of the object, you'll be able to redirect it. So with that, why don't I kind of show you a very quick demo. And let's bring it up here. Oops. Click on the demo. Yeah. Okay, on that. It's a virus. So this is going to show you just how easy it is to kind of do the bucket assignment policy. You're going to log in here into CMC, which is the Cloudian Management Center. You're going to see this a number of times.
You consider yourself tier 2, tier 3 types of storage, not tier 1?
Absolutely.
I mean, yeah, because you don't seem like you support flash or access
we
latency.
actually pride ourselves in being tier 2, tier 3 storage. What's going to happen in servers going forward is they'll have more persistent in-memory storage. That's where you're going to run your database, your transactional processing, your VMs will become optimized, whether it's through a converged system or not. Bulk of your data needs to be this capacity data. What you're seeing here is we're actually, so that's really our focus. What you see here is we're actually uploading a bunch of objects into CMC. This is just about to upload, or it's uploaded. And down here on bucket storage type, you can see you can actually change both the size of the object in terms of where I'm going to redirect small objects or not, but also whether I want to store it in a HyperStore file system or erasure coding. So you've got this ability to kind of selectively choose the policy on the fly. So really quick, you'll notice how we make it very simple. This is admin control, so admins can actually dictate, do I want to allow that to happen, or do I not?
So you have two partitions of storage. One's a file system store, and one's a erasure store. Is that erasure code
Actually,
store?
the way we store the data actually ends up exactly the same. What we're doing above that is we actually decide, is this erasure coded or replicated, and then we find out how many shards or chunks of data we actually need to put stuff into, and then we'll actually go through Cassandra and do lookups and find where I need to put data. So you're going to see a little bit more from Gary as he walks through a data path.
Are the same objects available as objects through S3 and files through?
So yes, we actually have an NFS. So the interface that we mentioned S3, I didn't mention NFS, but we have an NFS interface to our data as well. And when you access through NFS, the same objects are available via NFS or the S3 interface.
And can I do in-place updates through the NFS interface?
You can do in-place updates. They end up as basically new objects on our backend.
So you accept in-place update requests and create new versions.
But they become new versions.
Okay. Yeah. And is there any control over how many updates create a new version? Can I say, spawn a new version every 15 seconds or something like that?
I don't think there's that level of control. That's an interesting idea, though, but not that not
right, because you could, I can think of lots of applications where you'd update in batch. You're going to do in-place updates in batches, and then I want a version for each batch.
I think it makes a lot of sense.
Yeah, it's actually done. Internally, we split up any big file objects into chunks. So
okay, so
we will internally create a new chunk.
So there's sub objects.
Yeah, but you're not going to see that at the application level. Yeah.
So back to
it's nice you do it at all. So I'm not. Don't get me wrong.
Yeah. So back to the adaptive policy. You want to?
No. Next slide. So the file system.
Oh, this one. Yeah.
Versus file system versus not, I guess. So one's replicated, one's erasure coded.
Yeah.
Is that?
Yeah.
And the file system data is erasure coded, no, replicated, and the other one's erasure coded.
Yeah, we call
Can
it
erasure coded data be replicated?
So we call it a file system. Really, it's that's replica. In fact, we're changing that tag.
You got a bucket that's a replica bucket and a bucket that's erasure
It's a
coded.
replica bucket or a erasure coded bucket. Yeah, and on the, but remember it's dynamic. So on that bucket, you can change that policy if you need to. So if you actually decide that it's actually better to store that with erasure coding, you can do that.
Okay,
But erasure coded data is not going to be replicated, and replicated data is not going to be erasure coded.
Actually, we can combine policies. So we can have combination policies where, and a use case for this is imagine you've got, you want to have efficient storage, but I also want to have DR of my service. Then I'll want to actually have a local erasure coded policy within data center 1, and I'll want to have a mirrored copy over data center 2 with erasure coding on data center 2.
Yeah.
So in that way, I actually protect myself from the Japan earthquake disaster, but I get efficiency in terms of storage.
right, you don't have 4 replicas.
You don't have
but,
4 replicas.
But you don't have the latency of trying to recover shards across the WAN either.
Absolutely, absolutely.
But very small objects are always stored in Cassandra.
Very small objects are stored in Cassandra, that's right.
Okay.
And all is replicated.
Yeah.
And you make that decision dynamically.
Yes, yes.
Please don't expose that knob.
That's where challenges get in. So in terms of consistency, we have multiple dynamic consistency levels. What I'd like to do, I'll touch on hybrid cloud tiering really quickly, but as I mentioned, gateway shouldn't really be a separate technology, particularly in this capacity storage space. Build it into the storage platform. That's what we've done here. Effectively, you can set an archiving policy to tier objects off to Amazon. And with that, I'll quickly show you a very quick demo, and then we'll dive into the tech depth, where Gary's going to go into the tech depth.
This will be a video instead of live as well.
So, again, we shouldn't show the login screens, but but anyhow, but what you're going to see is a bucket, a pool of objects, and you're going to see us actually set a policy on archiving of that data. So we'll do it really quickly. So under here, we go to Data Explorer, which is just a way to navigate to your data. You'll notice on admin, we're going to go through this a little later, our console has the ability to give, there's admin interfaces so they can manage the systems, the system state, alerting on all of the systems. They can add and remove nodes on the fly. And then they have an end user data explorer so they can actually go and manage and push objects, as you see here. They're doing a mass upload of all of these objects. And once they've uploaded these objects, the end user is actually going to set the policy in terms of archiving that data. So you're going to see that in just a second. Properties, bucket lifecycle rule. Again, you don't need to worry about a different system at all. You're setting up transition of those objects to either S3 or Glacier. You can do it after a date, a number of days, or a timestamp, so it's effectively an archiving policy. It's something that we'll run all the time. You can set the different way that we will retrieve objects. Do we retrieve the objects by just redirecting and actually doing a direct pass-through? Or do you want us to pull the object back and actually have it back within our store?
So
and then credentials.
We're in the system admin context, correct?
We're in the system admin context. Depending on how you want to assign those policies, you can assign those out to a group admin as well.
And this is accessible via API?
Everything. Everything we do is accessible via API. You'll see that's one of the core tenets. I came from NetApp, and one of the things NetApp got right is they realized APIs to everything is the answer. And they then had a really difficult time when they transitioned between different platforms. But you must give API access. I mean, this is the new type of storage is totally programmatic storage.
So do you find people using this platform as a replacement for like a Centera for long-term archiving of data that they otherwise have to maintain?
So there's actually multiple use cases. That is definitely a very hot one. We don't do quite as far as a Centera. Centera will actually allow you so that the sysadmin cannot even delete objects and erase objects. Mm-hmm. We can do it down to the group admin level so we can control who's able to actually do certain stuff on objects, how long you want to retain data for, how long you want to expire data. So we can manage all of those aspects.
So reasonable retention, but not 17.4a.
Exactly. And that's something that we're looking at, I think, going forward, but very close, and it's something that's a very key aspect.
I mean, the near-term use cases are for people who want access to object data and to store it in S3 without having to manage S3 as S3. So they'll have a unified platform for the enterprise.
So a lot of enterprises want to move to S3, and the challenge is that they're just not ready to move yet. They want to move over all of their development processes over to it, all of their new app development. They want it to actually be based on these new APIs and standards. That's how they're building the new applications. This gives them a chance to actually deploy a cloud store pool, fully compliant.
In-house.
It's distributed, it's in-house, and then they can actually manage how much of their data do they want to take applications, build them there, and leave them there forever. Do they want to move them up to Amazon? They can do that. So it gives them complete flexibility.
So in a way, we could see this as kind of the DevOps, app dev QA Centera, and essentially
that's a lot of things in one sentence. But
just app dev, throw the whole group under the bus and say, hey, this is the way we can maintain a CSV for life. CSV, yeah.
Yeah.
What is really key here is that it puts the control of the policy, where the data is going to live, when it's going to move, in the hands of IT, right? As opposed to people putting Amazon onto their credit cards,